The first step to adding vectors is to take each vector and resolve it into its components. What are the components of a vector, though? We're going to talk about the x and the y components of a given vector, in this case, vector A. The components are essentially the projections of that vector onto the axes. It's handy that we're already given a picture here. What are we looking at? So we're told here that there is tension in this cable. So in this case, the vector represents tension, and that has a magnitude of 7.25 newtons. The angle of this vector is 62.0 degrees with a horizontal. In other words, if I draw this vector in standard position, I would draw it at 62 degrees and label it as it's done here. We're asked to find the value of a subscript x and a subscript y, the x and the y components of vector A. The way it's drawn here, hopefully you're starting to think the trigonometry can give us a hand. This dotted line is handy, so I'll draw in a right angle just to highlight that we do in fact have a right angle triangle. Let's start this way before we just jump into using formulas. What is the sine of 62.0 degrees? How would you describe it using this right angle triangle? So the sine of 62 degrees, sine is always y over r, opposite over adjacent, so this is y. We could also label this as AY, and r in this case is the magnitude of vector A, or 7.25 newtons. So the sine of 62 degrees is the y component of the vector divided by the magnitude, 7.25. That allows me to solve for the y component. All I have to do is multiply both sides by 7.25. This cancels it from the right-hand side, and we find the y component of the vector is the value of the magnitude, 7.25, times the sine of its angle, the sine of 62.0 degrees. So in this case, the y component of the vector has a value of 6.40 newtons. In other words, if I have a cable pulling at 7.25 newtons at this 62 degree angle, the force felt vertically is 6.4 newtons. The force on the point where the cable is pulling. So we came at the y component of the vector simply by evaluating the sine, by writing down what the sine of the angle was. Let's try the cosine of the angle. The cosine of 62.0 degrees, well, that's going to be x over r, adjacent over hypotenuse. So in our case, that will be the x component divided by 7.25, the magnitude. Once again, it's pretty straightforward to solve for the x component. So multiplying both sides by 7.25 allows us to solve for the x component. So ax is equal to 7.25, or the magnitude of the vector, times the cosine of its angle, the cosine of 62.0 degrees. Plugging that into our calculators, we find that the x component of the angle is 3.40 newtons. We could start this question in the same way each time, but going forward, we can apply the same formula. The y component of the vector will always be the magnitude of the vector times the sine of its angle. Similarly, the x component of the vector can always be found by starting with the magnitude of the vector and multiplying it by the cosine of its angle. So a little more generically, we could say that a subscript y is the magnitude times the sine of the angle, and a subscript x, the x component, is the magnitude of the vector times the cosine of its angle. This particular question asked us only for the single vector, and it only asked us to resolve it into its components. But going forward, when we add vectors, this will be the first step in each question. In this example, we're dealing with a vector that's not in quadrant 1. It's directed at an angle of 126 degrees. We don't know what the units are here, but we have a magnitude of 14.4. And similarly, this question asks us to resolve the vector into its x and y components. Let's start with a picture. So on the coordinate plane, 126 degrees is a vector, is an angle in quadrant 2. So I'll label this as 126 degrees, and we're told that the magnitude of this vector is 14.4 units. What we're asked to do here is to resolve this vector into its y component and its x component. Let's start with the formulas that we looked at on the previous slide. The y component of the vector is the magnitude of the vector, so 14.4, times the sine of its angle, where the x component is the magnitude of the vector times the cosine of its angle. For us, therefore, the y component, we'll find it by taking 14.4 and multiplying that by the sine of 126 degrees. And we'll find the x component by taking 14.4 and multiplying that by the cosine of 126 degrees. Before I run this calculation, what do you expect for these answers? That is, what do you expect in terms of the sign of these answers? Will they be positive or negative? Looking at the picture, I see that in quadrant 2, I must have a positive value for y. So I expect that this will be a positive value, ay. On the other hand, because we're in quadrant 2, we've moved in the negative direction along the x-axis, so I expect that for the x component, I'll end up with a negative value. And that is in fact the case. We find that y has a value of 11.6 units, and the x component a value of negative 8.46. Essentially, what we found here is the point, negative 8.46, 11.6, through which our vector passes if we draw it on the coordinate plane and place it with its tail at the origin.